Hey everyone, welcome. We're about to dive into the hidden science that connects, well, pretty much everything. Your morning coffee, the screen you're looking at right now, even the air you're breathing. This is the foundation of chemistry. All right, let's just jump right in with a question for you. I want you to look around right now. What do you see? Maybe it's the device you're watching this on, or a cup of water on your desk. What do all those different things really have in common? The answer is actually super simple. They are all made of matter. And right there, that's where chemistry begins. It's all about understanding what stuff is, what it's made of, and how it changes. Seriously, it's the foundation for everything. So here's what we're going to cover. We'll talk about why they call chemistry the science of everything. We'll get into how a chemist actually thinks, including these 3 secret levels, which is super cool. And then we'll wrap up with the basic rules that all matter has to follow. Let's do it. All right, first up, the science of everything. I mean, that's a pretty big claim, right? The science of everything. So let's define what we're actually talking about here and see why it's so incredibly central to our world. Okay, so the textbook definition is pretty straightforward. Chemistry is the science of matter. Anything that has mass and takes up space, and all the incredible transformations it goes through. Here's the key thing to remember. If stuff is turning into other stuff, you can bet chemistry is involved. And hey, this isn't just something for people in white lab coats, okay? This is happening all around you all the time. When you cook an egg, that sizzle, that's chemistry. An old bike chain getting rusty, chemistry. It's even happening inside your body right now. It is literally everywhere. So you might be wondering, okay, but what about physics and biology? Great question. Think of it like this. Physics is all about the big forces and energy. Like, why does a ball fall down? Biology, that's the study of life. How does a heart pump blood? But chemistry is the messy, interesting middle part. It's about the substances themselves and how they change, which honestly is what makes everything else possible. Yeah, there's this great saying that chemistry is the bridge between physics and biology, and it's so true. It's the central science. It takes the rules of physics to explain the stuff that makes life, live. It's the glue that holds it all together. Okay, so how in the world do chemists study this stuff? We're talking about atoms and molecules here, things that are so ridiculously tiny you could never ever hope to see them. How do they do that? Well, the short answer is they use models. And when we say model in science, we're not talking about a little plastic airplane. A model is really just a simplified picture, a tool that helps us wrap our heads around something we can't actually see with our own eyes. It's like this. A globe isn't the actual Earth, right? But it's a fantastic model that lets us understand where the continents are. In the exact same way, a model of an atom isn't a real atom, but it's a super useful tool for chemists to predict how a real one will behave. Now, when a model works over and over again and you've got tons of experiments all pointing in the same direction, you get what's called a scientific theory. And this is so important. A theory in science is not just a theory, like a random guess. No way. It's a powerful, well-tested explanation for why things happen, backed up by mountains of evidence. All right, now we're getting to my absolute favorite part. This is the real secret sauce of how chemists think. We're talking about chemistry's 3 secret levels. Seriously, once you get this, it's like having a superpower for understanding the world. So to get what I mean, let's just look at something super simple. A burning candle. To you and me, it's, a flame, it's warm. But to a chemist, there's a whole universe of stuff going on there. What do they see? They see it on 3 different levels all at once. First, there's the macroscopic. That's just what we can see, touch, and feel. Then they zoom way into the microscopic level. What are the actual atoms and molecules doing? And finally, there's the symbolic level, which is like the special shorthand, the language they use to write it all down. So back to our candle. Macroscopic, we see a flame, we feel heat, we see light. Easy. Microscopic, a chemist pictures tiny little wax molecules jumping off the wick and crashing into oxygen molecules from the air. And symbolic, they can just write that whole complicated dance down in a simple, clean equation. Being able to jump between these 3 viewpoints, that's thinking like a chemist. Okay, all of this thinking and modeling has led us to some really fundamental truths. This brings us to our last section, the laws of matter. Because here's the thing, chemistry isn't just random chaos. It follows very specific, very precise rules that never, ever change.
Let's look at two of the big ones. First, the law of conservation of mass. This just means you can't create or destroy matter. It's like Lego. You can take a castle apart, but you still have all the same bricks. If you burn a log, it might look like it's disappearing, but if you could capture all the smoke and ash, it would weigh the exact same as the original log. Then there's the law of definite proportions. This one just means that a specific chemical, like water, always has the same recipe. Always.
And water is the perfect example. By mass, it's always 1 part hydrogen to 8 parts oxygen. It doesn't matter if that water came from a glacier, from your tap, or from a comet in deep space. The recipe is locked in. It's a universal constant. Now, because these laws are so rock solid and precise, it means chemists have to be really, really careful and honest about their measurements. You can't just jot down a number. You have to have a way to tell everyone else, hey, this is how confident I am in this number.
So let's say a chemist writes down 10 grams. What they're really saying is, it's around 10. It's an estimate. It's not super precise.
But if they write 10.00 grams, now that's a completely different story. Those 2 little zeros at the end are a secret code. They're called significant figures, and they're shouting, I measured this very carefully, and I'm confident it's exactly this number. It's a huge part of speaking the language of science honestly.
Okay, so let's wrap this all up. What did we learn? 1. Chemistry is the science of everything changing around you. 2. Chemists use models and theories to see the invisible world of atoms. 3. The real magic is thinking on all 3 levels at once, the big picture, the atomic level, and the symbolic language. And 4. Chemistry follows strict laws, which means precision and accuracy are everything.
So here's my challenge to you. The next time you see something change, I don't care if it's toast browning or a battery dying, just pause for a second. Try to look at it with your new chemist's eyes. What's happening that you can see? What do you think is happening with the atoms? Now that you know the basics, what will you see differently? Thanks for watching.